Okay, so Dr. Peat, again, the kind of the misconceptions, things that we're told are a certain way, we find out they're not, and it becomes ingrained in our minds and our psyche, and people repeat it often. The blood-brain barrier, I mean, when I was studying physiology, I was told that the pia mater, the dura mater, and the arachnoid mater formed those meninges, and that the blood-brain barrier existed to keep certain pathogens and toxins out, although I know things like cysts can get into the brain, and they're certainly a pathogen. What's your opinion? I know you have a very fluid understanding of the body and red blood cells and how they definitely move around a lot, and how communication is just not the way you'd read it in a normal 21st century physiology text. But how do you understand the blood-brain barrier and its function?
It relates to the general idea of integrity of tissue and cells, and when something goes wrong with the tissue, an energy failure, for example, any tissue loses its barrier function or integrity, and things that are inside leak out, and things that are outside can get in. And different tissues are composed of different degrees of fatty material and proteins, but every cell, when it's in a highly energized state, the whole cytoplasm has a fat-loving property, a hydrophobic property. The idea of a membrane barrier on the surface of a cell is really a myth. Gilbert Ling spent 40, 50 years disproving that myth, that it's really the structure of the cytoplasm that creates a barrier between any cells inside and its outside. And Russian researchers in the middle of the last century showed that the energy level of the cell is what governs its barrier function. High energy state, the cell has a lipid-loving quality, takes up fat easily. And when it's de-energized, a water-soluble dye will leak in it. That has been demonstrated for more than 100 years on simple organisms as well as tissue culture. So it's really an old idea, but about 50 years ago, someone demonstrated in rats that the lipid-loving quality of the brain is what governs the so-called barrier function. The brain has to live at a very high energy state, and in that high energy state, it's more hydrophobic, more fat-loving.
Okay.
And these researchers put an emulsion of, I think it was soy oil, into the carotid artery of a rat, and then measured the content of the blood coming out of the vein draining the brain. And they found that on a single pass through the brain, 17% of this fat was taken up from the blood.